In this video, we will define the basic circuit variables such as current, voltage, and power that are used in circuit analysis. We begin with the definition of current, which is defined as the rate of change of charge. If we denote current with the variable I of t, then this is equal to the differential of Q of t. The current I of t is flowing through an element. If we represent an element with a black box, which is connected between terminals A and B, then the current is flowing in from one terminal and is shown by an arrow, and flows out of the other terminal, again shown by an arrow. For ease of representation, we will simply draw one arrow next to the element and write down the current I of t next to the arrow. This direction of the current is called the reference direction, which is that we are making an assumption that the current is flowing from A to B. The actual value of I of t may be positive or negative, and if we have a graph for I of t which may have a shape like this, between 0 and 1 second it is positive, and between 1 and 2 seconds it is negative. So what this means is that we can break up into two cases. Case 1, which is the time interval from 0 to 1 second, where I of t is positive or greater than 0. What this means is that positive charged particles are actually moving in the same direction as the arrow. Or equivalently, negative charged particles are moving opposite to the direction of arrow. In the second case, when the current is negative, which is during the time interval from 1 to 2 seconds, I of t is less than 0. What this means is that the positive charge particles are actually flowing from B to A, or equivalently, negative charged particles are flowing in the opposite direction. Thus, we can set up the direction of current to be in any direction and then interpret the value of the current that we obtain appropriately. The units of current are called amperes, and if written in full, we write it with a lowercase a, and when written as an abbreviation, we simply write it as a capital A. 1 ampere is equal to 1 coulomb per second. Next, we will define the variable voltage, which is also called the electric potential, or simply the potential. Voltage is defined as the differential of work with respect to charge. The voltage V of t is defined as the differential with respect to charge of the work done, where we are representing the work done as U of t. Voltage is a quantity that is measured across 2 points. Once again, if we draw an element as a box which is connected between two terminals A and B, then the voltage V of t is the value which is measured across the element or from point A to point B. We usually give the voltage a reference direction by putting a plus sign on one side and a negative sign on the other side. This is the reference direction with respect to which we will measure the voltages, and if the voltage has a graph as a function of time, it changes as shown, such that between 0 and 1 second it is positive, and between 1 and 2 seconds it is negative. We can interpret this as two cases. Case 1, which is in the time interval from 0 to 1 second, where the voltage is positive or greater than 0. What this means is that the terminal A is at a higher potential or at a higher voltage as compared to terminal B. In the second case, which is during the time interval from 1 to 2 seconds, B of t is negative. What this means is that the terminal B is at a higher potential as compared to terminal A. Thus, it is important to set up a reference direction and interpret the value of the voltage appropriately. The units of voltage are called volts, and we write it with a lowercase v if we are writing it in full, or as a capital V if we are writing it as an abbreviation. 1 volt is equal to 1 joule